Hello and welcome to my little data over audio web page project where I'm trying to send a digital signal through my laptop's speakers and then back into my laptop's microphone and translate the audio signal back into the original data. I didn't make a video yesterday because I was introducing packets or separating my data into multiple packets, and the application was in a pretty bad state. However, I have recovered the majority of the state so that I can actually use the application again. And I will show you how that works. And I'll just make this into a message you can read and understand and send that. All right. So you can see all the data is now split out into multiple packets. I've got a lot of statistics here, pretty much saying how many packets I'm going to use, what the packet size is, how long it's going to take to transmit, all kinds of goodies. And then I do a lot of stuff down here where I'm actually receiving the bits. I'm looking at what the encoded bits are after this is after deinterlacing, but I don't think there's any interlacing right now. Okay, no, there's not, just because there needs to be at least 8 bits or more for interlacing to actually have a pretty good positive impact for now. Actually, I've thought about that. There's actually a benefit if I do it a different way. Now that I have packet sizes. Before I couldn't do it, but I was on the cusp of trying to do it. We'll get to that another day, though. But anyway, now that I have all my packets, I'm able to correct errors in the packets. I just don't know if there's an error in the packet. And so the big thing I've been working on today was this CRC checking, which is cyclic redundancy checking. I've done 8-bit and 16-bit. 32-bit should work just the same, but there's an issue going on, and I think it's due to the bit operating system, or what kind of integer values I have in JavaScript itself in order to work with. And then I think signed 4-bit integers are causing a problem. I'm not quite sure, but that's what I think is happening. But since we're dealing with such small amounts of data, it's not really that big of an issue to go into CRC 32-bit error checking right now. What I'm applying the CRC to right now is this byte count. This is the most important thing to me right now, because once I have the byte count, I'm actually able to trim all of my decoded packets and coded packets so that only the bytes that matter are being displayed. If you look at these segments, you'll see all these zeros, because I have a fixed packet size, but none of these zeros appear at the bottom of packet 2. Packet 2 is much shorter than 0 and 1, even though the packet was the same length as all the other packets. Oh, I didn't want to go down there. Okay, so we did have one error with that, but that's just 1 bit. We can recover from that, and so we have recovered. Now the CRC check tells me that this value is actually what was sent. So this CRC checking is only for a 16-bit number. It's just checking 4 individual bits to see if the value matches. If the value doesn't match, well, then we have a problem. That means we cannot trust that this is the length of bytes being sent to us. All right. Now, once I have the bytes, not only can I clip off additional bits I don't need, I can now actually show a progress bar as well. So the other cool thing is now I have a byte count. I can do more stuff. With padded packets, you've probably heard all the zeros as a solid tone at the end. And you can see the dash line represents a 0, and the solid line represents a 1. And so this channel was sending zeros for many segments. Same here, same here, same here, same here, same here, same here. So all those are zeros at the end. Right now, this is part of the problem I ran into yesterday. I lost a lot of, I didn't lose a lot of data. Things changed in memory. I need to change how these channels get the information. It just so happens that number 36 was the last packet from the last segment from the first packet, and then it ignored everything after that. So I have to change the frequency graph to address multiple packets. Then I also have to address how to get the expected versus the incorrect, or the expected value and the received values have to change based on the channel and the segments. So all those are missing zeros and ones. Anything else? Some of this is wrong. Now that I have multiple packets, this was based off of everything being sent as one entire packet. This has to change. That's it. I think we're pretty good. Yeah. All right. Take care.